Hello everyone. So let's continue. So recording again. I'm sharing my screen with you. Sharing, sharing. Hopes you see my screen. I'm going to put in the slideshow mode. So understanding basic statistics. That's the topic. You must have studied in other courses. Understanding basic statistics. So random variable. So a variable is basically an attribute that reveals, okay, certain characteristic of an object or an entity. Okay, so in object oriented programming or systems analysis, anything is an object. So in systems, SSAD, like, systems analysis and design. Okay, so and random variable is anything that you want to really find out information about. So basically it quantifies, the outcomes of random occurrences about the random variable. For example, so I want to go to Hershey factory, Hershey, so the chocolate factory, Hershey. So I want to get 50, I want to saw that 50-gram chocolate bars. So I took a sample of 100 bars and I weigh them. They're supposed to be 50 grams. So, but they're not exactly 50 grams. One is 49.9, another is 49, another is 51, another is 52, another is 50.5, another is 50, another. So you are actually finding out the weight of each of the bars, and they are not exactly the same. So until you weigh them, you don't know what the weight is. So that is a random thing. When you're weighing, you don't know what the value is. Once you already weighed it, it's not random anymore. So, but before weighing it, it could be anything random between certain values. Okay, you want to find out all those, how many of them are 49.5, how many of them are 49. That's a kind of frequency plot is data distribution. So how many of them are or something like that. In x-axis, these values are on the x-axis. This is a random variable is on the x-axis. So all of them, 50 gram is here, 51 is here, 49.9 is here. And then how many of them, how many of them among 100 are these values? So you find out, the tip of these bars here is the frequency distribution. Or you can convert that to probability distribution. So probability is never more than 1. Okay? So probability distribution. You're converting the frequency distribution in terms of probability distribution. If the more frequency here, more probability, a likelihood of happening. So with that knowledge, you will be able to actually plot a distribution. Basically here, when you got these values here, so you want to plot them and create some bins. Okay? Bins. Okay, so and you actually plot them in bins and the number of values in that bin. So for example, 2 to 7, 7 to 12, 12 to 17, like that. These are bins. So ranges, basically ranges. So and then you collect in the frequencies for the all the values that are inside this bin. For example, okay, 2 to 7, right? It's probably 2. Okay, and the 7 is here. All right. So all the values are here, and their frequencies are whatever is 7,500 of them are in that range of values. Okay. I think it appears like he didn't do right job here. Let me see if it makes sense. So the brackets have notation. Square bracket means include bracket. A regular parenthesis means exclude bracket. This is the notation. So obviously you want to include this. But you don't want to include that. I think it's a typo here. You can put exclude that. And then include this and exclude that. Include this and exclude that. That's a normal way of doing it. Most of the people do like that, not the other way around. But it's okay the way he did it. But you cannot add the same thing in two bins. So let me come back again and try to see if he is adding the same value in two bins. So the 7 is included in this bin, excluded in this bin. Okay? The 12 is included in this bin, excluded in this bin. 17 is included, excluded here, included, included here, excluded here, included here, excluded here. The last one is included. So it's okay. To me, it sounds okay. But the issue is, so when you are thinking about, you know, discounts, for example, so you're buying, 0 to 0, you don't get any discount anyway. So 1 to 100 items you're buying, you get, 5% discount. Okay. 100 and 100 to 200, you get 6% discount, something like that. Then you put 100 is here, 100 there. So where do you want to include? Here or there? Usually here, not there. So So you want to put that include bracket and exclude bracket. This is include, that is exclude. This is include, that is exclude, and you continue to do that. So the distribution is about, can be continuous if in the random variable can have decimal values. Okay, then it is a continuous distribution. If you take the continuous distribution and then actually plot them, you get continuous distribution. So whereas the whatever collected the data and you created bins, like a whole number bins, and then you plot them, okay, then you get the discrete distribution. The data itself can be discrete. Sometimes you buy, counting the number of apples, number of items in the inventory, number of vehicles. These cannot be, decimal values. So whereas the height, the weight, those ones can have decimal values. So when you have decimal, you can have infinite values. Even though, for example, 1 to 2, so there can be infinite values between 1 and 2. Because 1.00001, 1.0, you can put any number of decimal places, right? So infinite. So finite means, the number of values you can have are finite. So mean value you can find out. So that tells you the central tendency of the data. So the sum divided by the number of values. Sum of the value divided by the number of values. N is the sample size. You must have studied in other courses too. Median is the midpoint of all those values. Mode is most frequently occurring number in the observation. Symmetry. Normally, in a perfectly normal distribution, the mean is equal to mode equal to median. Kurtosis is when you don't have a perfectly the balance or symmetrical distribution, then you have a shape factor. The shape factor. The shaping factor is called kurtosis. So the data is not central and it has no tails. So then you have kurtosis. So data is central means kurtosis is 0, positive kurtosis, negative kurtosis. Positive kurtosis is skewed to the right like that. Okay? Scoot to the left like that. So more long tail is here. Long tail is here. So mean value, how to find out the mean value among the data set of values here. 1, 2, 3, 4, 5, 6, 7, 8, 9 values are here. Add all of them. So divide by 9. So you got the mean value. So you want to find out the median. The mid value you write down in the sorted order. All the values you need to write down in the sorted order. Don't forget. Ascending and descending doesn't matter. So the middle value, if you have two values, you take the average of those values. That is the mean value, median. Mode is most frequently occurring. The 4 was most frequently occurring. I would take 4 as a mode. So if you have exactly the same, mode for two numbers, then whichever comes first in the sorted order, that will be taken as the mode. So mean, median, mode. Okay. So mode is most frequently occurring number. Okay. They're all, in a perfectly symmetrical distribution, they're all supposed to be the same. Same, supposed to be. Not exactly the same acceptable range. So range is the maximum value in the sample minus minimum value in the sample. Mid-range equal to minimum plus maximum divided by 2. Min plus max divided by 2. That's a mid-range. Is not the range, mid-range. So interquartile range. So you divide the values, observations, all the observation you did into 4 quartiles. So for quartile means 25th point, 25th percentile point. Okay? So the median itself is the 50th percentile point. The variance is, the deviations, squared deviations from the mean value. You take a random variable, it is deviating from the mean value. Mean value is x bar. If x is a random variable, so x bar is the mean value. If tala is a random variable, this is my name. Tala bar is the mean value. So look at yourself. You are not the same all the time. You are random. Your mood changes every single day, every minute actually. But you have an average behavior. And that is the average. At any given point of time, you are like this. Your deviation from the mean value, you are probably a too nicer than the mean, or not nicer than the mean value. The difference is x minus x bar. You take that and square it, and sum of all those values, like one value, another value like that. Okay? And you take the average of those values, that is the mean. So in some definitions it's average. In some definitions it is divided by n minus 1. N is the number of values. Sigma I equal to 1 to n and divided by n minus 1. Okay. So standard deviation is square root of the variance is the standard deviation. Square root of the variance. Okay. Coefficient of variation is the standard deviation, okay, is divided by mean value. E is the coefficient of variation. Is also widely used statistical, okay, value that you want to really look at. Imagine that you have the data at the daily temperatures. These are the values in the city, like here. So 1, 2, 3, 4, 5, 6, 7 values you have. Mean is this. Okay. So mean of this other one, city B, is this. Are both the mean the same? Obviously, they are not looking same. But can you conclude that both are almost the same? So you can do statistical analysis if you wish to. Okay. And then, you in advanced statistics, you do that. Variance is a measure. So you can find out x, x bar is here. 26 is x bar, x bar, x bar, x bar. All values are here. And 7 values, and that is 2.57. Okay. All right. And the second one is these values, and that is 28.57. City B, variance is significantly different. Okay. So this is the one, that's the one. It looks different. You look at it. So 15 minus this 7 here. So like, almost like 9 there. Look at that significant value. Here, all of them values are close to the mean value. Okay. But still you can analyze and try to find out. So that means, and are they same or not? If you look at the mean alone, you will not get that idea whether they're same or not. Okay. So you have to do other analysis. So standard deviation is this, because the standard deviation is very low because of this, whereas standard deviation is 6 point, okay, for the city. So coefficient of variation is 6.15, whereas city B 25.4. So significant variance here. So obviously, you have your mean value, even though they're close to each other, doesn't really mean the same. So interquartile range, you first find out quartile. Quartile is Q1 is 25th quartile, and Q2 is the median, Q3 is third quartile, okay, Q4 is the fourth quartile. So those are the quartiles, okay. So the Q2 value is the median. That's what I told you earlier, right? So now you look at here. So these are the values that I gave you here. How many values you have? 8 values. So middle values are 26, 26, and that is the average of them is 26. That's the median. You take the rest of the values which are in the red. So that is the first quartile. The median of this one is 25, 25 divided by 2. So median of the lower half. So median of the upper half here, 27, 28, the 27.5 is the median of the upper half in the blue color. The difference between Q3 and Q1 is interquartile range. So 25, Q 27.2.5. Suppose the data has odd number of values. So median is 26 straight. So you take these values and find out the median, which is 25, and find that these values, median is 28. So your interquartile range is 3. 28 minus 5, 25. All right, I hope you understood that. So if you look at perfectly normal distribution is also called a Gaussian distribution. Most of the engineering people call that as a Gaussian distribution. But most of the business people call that as a normal distribution. Okay? So, and that distribution has a, you can even say normal distribution. So 68% of all the data points are here on the x-axis. And the frequencies or the probabilities are on the tip of this. This is a frequency distribution or probability distribution, probability density function. How densely, populated there. So now you'll have 68% of all this area here. The entire area under the curve is 1. Sum of all probabilities is 1. All the probabilities here. So the area here is the probability. The sum of all the area here is 1. So, but if you take this part here, 1 standard deviation away. So 1 means 1 standard deviation away, plus or minus. And that area here is 68%. Okay? And the 2 standard deviation is 95.4%. So 2 standard deviations away. 3 standard deviation, 99.73 or 7%. So that includes 99.7%. So you can be saying that, okay, 3 standard deviations can be acceptable. Anything beyond that is not acceptable. Why are you cooking some meal? Because you want all the meals to be in good condition. But it is highly unlikely or impossible for you to get 100% out of your what you cooked also, because when you are serving, you leave out some of them, and you are, don't eat something which is on the sticking on the down below, and that could be very low. Okay. So that standard deviation is a kind of measure for you to say that the perfectly normal distribution. So the biggest value and the lowest value so will be 6 standard deviations away, 3 standard deviations the other side of the mean, 3 standard deviations on the other side, are the opposite side of the mean. So standard normal distribution. So most of the time people assume normal distribution. That's why we call normal distribution. It's a theoretical distribution. So obviously, you know what, when randomness is there, everything is theory anyway. So mean, median, mode can be normalized to 0. What do you mean, sir? So I would like to create convert the random variable x to another variable called z. This is a transformation or conversion. How do you convert? We know that, so you know what? The x is deviating from the mean. So x minus x bar is the deviation. So x minus the mean is the deviation. Okay? So for example, I buy 50 apples and I ask you how many dozens you divide by 12. Those many dozens you have. So this deviation, if I divide by standard deviation, so you will get a value which is the number of standard deviations. Just like you got, so many dozens of apples here. So the Z value or Z score people call normally is the number of standard deviations, okay, that the difference between x and x bar, sigma, x and x bar, not sigma, x bar is representing. Sigma is standard deviation. How many standard deviations is a is the deviation from the mean? Uniform distribution means all values here in the x-axis are equally likely. So that's what it is. You understand me? So if you know the number of values, you can immediately tell what that is. How can you tell, sir? When you multiply this area here, must be 1. This area must be 1 because area of all population distribution must be 1. If this is 10, what is this value? When you multiply that, you will get 1. That is 0.1. 10x equal to 1. So x equal to 1 by 10 equal to 0.1. So which means that, you know what? The probability P for all these values, P equal to 0.1. Nothing more, nothing less. Okay, using software tools to create summary statistics. There are so many tools you could actually use. Okay, Excel or Minitab or Tableau, Power BI. All of them, all tools will give you descriptive statistics one way or other. You know what? You have a lot of functions in Excel that will get you the mean value. So one function is average, median, okay, mode, and a skew. Max minus min is the range, quartile, excluding or including or whatever. So quartile, box plot, standard deviation, okay, different ways of population standard deviation, variance that of sample, and then what, valuation of the population. So you know what, if you go your Excel data analysis, okay, tool pack, and then data analysis, I can show it to you if you wish. I think I did show you earlier. So descriptive statistics, I can show you. Don't lose anything by looking at it. Only that Excel should be loaded there, right? I'll go here, Excel. Our friend is Excel is here. And then you can take that, for example, here, right? So here, so when you click on the data, and you should get the analysis tool pack in the corner here. I will get it because I installed it. See, data analysis tool pack here. So only when you click the data, you get that. If you don't get that, you have to add that. How do you add it? You go to the options. There is the add-ins. Okay, there is the add-ins, and click on the add-ins. And inactive, so if it is not added here, it will be in the inactive. Select that inactive, whichever, wherever that is, and click on the go and check mark whatever the thing you have, click OK, and it will come back here. So if you click on this one here, you will see the statistics here, descriptive statistics here. Look at it, descriptive statistic. And click OK, select the data and try to give So you'll get the descriptive statistics. All right, we are very close to completing this. So descriptive statistics, and the values will come here in the report format here. Mean, standard deviation. Okay, some more values you'll get, R square, and so on. Okay, skewness, kurtosis, and max, min, count, the number of values. Okay, so in Tableau, that you can do the same thing. So you can go to the worksheet and show summary, and then you get the results in that format. So interpreting and visualizing statistics. So when you have the numerical data, okay, so many values of X, you can create classes or groups of them. These are called bins. So, and then you can actually plot them, right? You know what? The frequencies in that bin can be counted, okay, before using them. For example, the values which are here from 0 to 650 are, I'm going to classify them as an interval of 50 values. 0 to 50, 50 to 100, 100 to 150, like that. So 50 is not included here, but included here. So all values, you get them, including decimal if you have. If you don't have decimal, no problem. Okay, if you have decimal, then, they also can be classified. And the frequencies of them are this. Okay. So, and plot them. And that is actually the distribution. And such a bar chart is called histogram. Histogram, x-axis is the ranges. Bar chart, normally x-axis is atomic values. So finally, the box plot will get you a good understanding of where the performance of, okay, the study is. For example, so, you're playing a basketball or something. So, and this is representing the score of the basketballs and so on and so on. So this is the first quartile value. This is the third quartile value. The median is here. The mean is here. Okay, this is the interquartile range. So now the max value is this, min value is this in your thing. So getting performance here is not easy. So most likely you will be around here. Even here, you are more likely to be close to, and this is a higher area than that. So more likely you will be in this area, okay? So than this area. So more likely. So it's about more likeliness. So that's about it. So I will post the videos, and also I'll post the lab too. Good luck, and we'll work together. Thank you. Stop sharing and the video.